get a yellow? Did you yellow? Yellow?
Yes.
Did you have a yellow? Did you have a yellow?
I think I do, yeah.
Did you guys get the yellow? There we go. Yeah, for next period. So it helps me get ahead. Thank you, though. Okay, look up. Okay, listen. Look here. Everybody look. Everybody look. Look. Okay, 3 packets. Here's why. We basically are done learning new things. Like there might be a small idea here or there that we'll have to spend time on together, but you have all of the big concepts you need to succeed. I always have these dumb rhymes. For this test, okay? That test is a week from tomorrow. Look, the biggest thing I need to help you do is overcome an idea that is not going to help you be successful. Like if you go into this test thinking that you're expecting to see problems that you've seen before and you just kind of do the same thing you've done before, you will do very poorly on the test. Like you won't do a little poorly, you'll do very poorly. There's 25 questions, you'll get like 4 of them right, okay? You have to have a different mindset. Listen close. 1 second. You have to go into the test thinking, these are all brand new problems, so I'm not going to expect to know how to do any of them, but I'm going to know how to find my way through them. Okay? You have to start with that mindset. If you start with the mindset of, we didn't learn this, yeah, you won't do any of them because they're all different. But every single problem has the concepts that we've been practicing. Yeah, Sydney, please. So the format of the test is 2 points for Sydney. It's exactly the same format as this yellow practice test and this blue practice test. So 25 questions, all multiple choice. And all have to be completed without a calculator. So just, yeah, all no calculator. Jay? So if you look at the sheet that we passed out here that we put in the sheet protector, the definition's on there, Jay. So if you don't have it, you can come up and get another one. So, okay, look up. So today, today's Thursday. Thursday, Monday, and then Wednesday, in class, all we're doing is trying to get you to change your mindset from, I don't know how to do that, to, I must have some sort of knowledge that will help me find my way through it. That's what we're going to be doing for all 3 days, is just learning how to overcome problems you've not seen before. Interspersed with that, there may be here and there an idea that we do have to discuss a little more thoroughly. So read the name for me. Who is it? Rachel. She's right here. She's very excited to get the mail. So I can just see the excitement on your face, Rachel. So. Okay. So anyway, these 3 packets, this one is technically the last homework assignment. Therefore, there are answers on the back. But you really should treat it like a practice test. Like you should treat it as, okay, I've never seen these problems before. They're all AP problems. It's a really good test of your knowledge. Like how many of these problems do you look at and say, I don't have a clue? Well, you just got to change your approach. Like when I look at these problems, I don't have a clue either. Like I'm serious. Like I have to go back and find a rule that's going to help me. These 2 are labeled as practice tests. Be very cautious. I've talked to many students who tell me in previous classes, practice test meant copy of the real test with different numbers. This is not that at all. These are just 25 problems to just give you a sense of what it's like to do 25 test questions. You could memorize all 50 of these and still get 0 on the real test. Because it's not about memorizing a problem, it's about understanding an idea. Questions. Okay, I hand them all out today because I want you to get as quick of a head start as you can. Like due dates, like I'll probably pay for this one when you come back to class on Monday. These two I won't ever give out tickets for. This is a college class. I'm treating you like a college student. In college, they give you a handout at the first day of the semester and say, here's when everything happens. They never remind you. That's it. Like you've got to stay on schedule. So I'm giving these to you today in preparation for the test next Friday. Your job is to use them to your advantage. Once you finish them, like you take it like a test, you go into Canvas, you can grade it. There's a way to enter all your answers and see what score you got. If you get some of them wrong, you can go back, use help from me, from anyone else, use videos to figure out what you did wrong, and then you can retake the test. That's fine. You can do as many times as you want to get a perfect score. Highly recommend, if you want to get an A in the class, you're going to need a perfect score on both of these. So you just go back as many times as necessary until every problem makes sense. Okay? Questions? So there will be no more handouts prior to the test itself. This is it. Like I wanted these in your hands as quick as possible so that you have as much time as possible. Not a big fan of, hey, here's the practice test. The test is tomorrow. Or worse yet, the junior high method of like, we will review the first half of the period and then we'll take the test the second half. Yeah, smiling because you know that happens. And they just like show you how to do everything. They leave the notes on the board and then you sit down and just kind of figure it out. Yeah, welcome to college. So, actually, college calculus, which is much harder than many college classes. Please. Yes. I will say there are a few exceptions in the blue. So everything here is an AP question. Most everything here is as well. There's a few I had to invent myself because I couldn't quite find enough AP ones. You can always tell Adelie by this. If there's a year in the corner, then it's an actual AP question. You are correct. No, it's perfect. Yeah, no, there's a few where I had to invent something, but you'll see that most of them are. And then the ones on the real test actually are all AP questions. So, good question, Adelie. 2 points. Anybody else? Okay, so here's what we're doing today. We're going to actually start with a problem from the Buff packet because I meant to kind of discuss this one in class and I ran out of time. So go to the Buff packet, go to problem 28. Okay. Okay, look up. No one talk. Shh. Focus hard on this. Okay, this is a real AP question. It is a great example of how the AP test writers can create a problem that requires zero computation. It requires really zero writing. It's simply reading and understanding and then picking the correct answer. The test you take next Friday is full of problems like this, where you're not going to write hardly anything. You just have to understand and analyze. I've had many students tell me, this isn't math. Like I'm used to math where it's like step 1, step 2, step 3. I argue that's not math either. That's just rote computation. Like, to me, it's all about can you think? Okay, employers don't pay for rote computation. That's what we buy computers for. That's what they do. Okay. Anyway, there's a big idea here that mixes everyone up, including teachers. Here's the big idea. They're talking about a particle that is moving. I've said it before. You should not look at these graphs and think particle. You should look at these graphs and think numbers. So it says a particle starts from rest at the point 2, 0. There's keywords there right away. Here's all the keywords. Starts. That means time equal to 0. starts from rest. That means at time equals 0, the velocity is 0. When you read that in any AP problem, that's how you translate it. Questions? Okay, on the point, at the point 2, 0 moves along the x-axis. Okay, so here's what you have to do. You cannot look here. You cannot look there. If you do, you'll step in a trap. You have to remind yourself, the particle is not here, it's somewhere else. So here's where the particle is. It's over here on its own grid. Okay, notice I did not call this a graph. It's not. This is not a graph. These are graphs. This is a grid where the particle is located. It is located at this position, right here, when time is equal to 0. So that circle represents the particle. Questions? So that's what we know so far. But we're supposed to translate this information into a mathematical graph. We're supposed to plot the distance of the particle from the origin. So everyone who knows, raise your hand, I'll pay you. At time equals 0, raise your hand. What is the distance of the particle from the origin? Hands up. Don't overthink it. Jackie. How many agree? 2 points, 3 for Jackie. So you come over here and you make a table. You say, at time equals 0, the distance of the particle from the origin is 2. Anyone feeling confused at all by what's over on this side of the board? You should not be looking here yet. Is everybody good here? Please. Say again? Nope. Good question, though. 2 for James. This point right here is 2, 0. Okay, raise your hand if you know exactly what this 2 is telling you. Like what is that 2 telling us? Hands up, come on. What's that 2 telling you right there? A few blank looks. Let's go, Stephen. Just how far it is from the origin. It's sitting 2 away. How many knew it? 2 points. Okay, the 0 right there, here's what the 0 means. The particle is located on this line. If the particle were on this line, like that, or maybe this line up here, the particle would be at 2, 3. So the 3 is just the vertical location on this grid. Questions? The 0 is just the vertical location on the grid. The 0 isn't time. Time is this statement right here. The particle starts at time 0. So they tell us this is time 0, but that 0 has nothing to do with that 0. That's where they trick you. You think these zeros are related. They're not. It's the AP test. They're asking you to understand the numbers, not use them. You're used to classes where you didn't have to understand numbers at all. You just had to use them. Plug it into this formula, grind it through this process, get some result. Please. Like the key thing, James has got it, is the particle is here. It's on a grid like Battleship. You guys know the game Battleship? Yeah? Okay. It's on a grid. That's it. It's not a graph. It's not math. This isn't math at all. This is just, that's where it's located. Everybody good? Okay. We're supposed to translate this into a graph. Well, if you're going to put that on a graph, this is the x, this is the horizontal coordinate, this is the vertical. So you put a dot right there, like that. That dot is telling you when time is 0. See, remember, this isn't the particle, it's just numbers telling you something. That 2 right there is telling you that at time equals 0, the particle's over here on this grid. What mixes everyone up is that's an x coordinate, that's a y coordinate. you're using a y-coordinate to talk about an x-coordinate because they're two different things. Questions? So nearly every student who ever does this problem picks this, they get it wrong, and like, how did I get that wrong? It's like you're misinterpreting the numbers. You're just trying to quickly say, well, that says 2-0, that's 2-0, I guess that's the right answer. It doesn't have any meaning, it's just a guess. Questions? Please.
So, I know the answer is A, but how do you know that it's A and not B?
So the key is right here. 2 points for Ellie. The particle moves with a constant positive acceleration. Okay, if I'm plotting the distance from the origin, that's the same thing as plotting the position. Good with that. If my acceleration is always positive, my position graph must have a concave up shape.
So why can't it be, because, like, with B, it's increasing, so that would make the rate, the velocity be positive. Would it just be a straight line, though?
Let's keep going here, Ellie. You're doing great. So everybody in the room, raise your hand and tell me, what is the meaning? That is not the particle. That's a number on a graph, 0, 2. So raise your hands and tell me, what is that 0, 2 saying? Come on, hands. What does it say? Like, this class is all about you must interpret the meaning of the numbers. Got about half of you. Let's go, Adelie. Time is 0, it's sitting right there. How many knew it? 0.2 for Adelie. Okay, now tell me the meaning of this number. Let's put some numbers on here. So this is 1, 2, that would be 3. So right here, kind of looks like we're at 1, 3. Hands up, what is that telling you? What is that number telling you? There we go. Josh. So now the particle is here, and the time is now 1 second. How many knew it? 0.2 for Josh. And we go one more over. So we go here. So that's 2, 4. Hands up. What is that telling you? What is that telling you, Eric? So now over here, how many knew it? 0.2 for Eric. Okay, hands up. How rapidly is the particle changing position? Hands up. How fast, what's the rate at which the position is changing? How fast is the position changing? Alex. So it doesn't go up one position. It's okay, it's okay. Yeah, we don't want to think up. It's not up at all. Particle's going this way. But every 1 second, particle moves, we'll say 1 meter. So it moves 1 more meter to the right. How many knew it? 0.2 for Alex. Hands up. Is the velocity changing or is the velocity constant? Hands up. Is the velocity changing or is the velocity constant? Abby? The velocity is constant because the velocity says how fast the position is changing. Every 1 second, the position moves by 1 meter. That velocity is not changing. How many knew it? 0.2 for Abby.
Are we talking about B, the graph there, and not the A?
Right. The question was, A is the correct answer. Why is B not the correct answer? I was just going through what the numbers are telling us so it will reveal. Keep going. That is correct. That is correct. So right here, the velocity is constant. Okay, acceleration tells you how fast the velocity changes. So if the velocity is constant, the acceleration is 0. So this graph is depicting a moving particle whose acceleration is 0. Does that help, Ellie?
Yeah.
Okay, please.
How is the acceleration 0 if it says on the question, move along the x-axis with a constant positive acceleration? So that acceleration is changing velocity. So
No, you're right, Jay. That was the question. The idea is that the particle does have acceleration, therefore the correct answer must be A. And so we were just going through a reason why you can see that B is not correct. Yeah, good call. 2 points. Ellie, you good? Okay. Matthew.
Do they ever give you a problem where the points like 3, 1, you'd have to use the Pythagorean theorem to get the differentiable?
Oh, really good question. We will encounter some things like that later, and you will use the Pythagorean theorem. Anybody else? 2 points for Wyatt. Okay, go to the pink packet.
Do I do number 4?
You'll have to come after school for that one, Jay. Sorry. Go to the pink. Or you have the lab class too, right, Jay?
Yeah.
Yeah, you can ask in the lab. So go to number 3. No, sorry, 2. Before we talk about number 2, I want to illustrate what you see here. On the test next week, next Friday, you must be prepared to recognize symbols that may look different but have the same meaning. So the purple are all examples of different functions they may talk about in a given problem. The red are all examples of what a first derivative of the purple might look like just lots of different ways they can write the first derivative of the purple. And then the blue is many different ways they can write the first derivative of the red. So everything in blue is a first derivative of the red. Everything in blue is also a second derivative of the purple. Just many different types of symbols. Questions? Awesome. So here's number 2. Okay, as I tried my best to explain when we started the class today, the goal of today, Monday, and Wednesday is to get your mindset to shift from an idea of I see a problem and I know how to do it to I see a problem, I don't know what to do, therefore I have to figure my way through it. So here's a perfect example of that. This is a genuine AP problem. It is a problem no one in this room has seen before. I don't need to teach you anything new to solve this problem. You just have to use what you know to solve the problem. So what I'm going to do is I'm going to give you, on the test you can take maybe 2 minutes to solve this at most, because you have 60 minutes to get through 25 problems. So you're going to work on that. You should start all by yourself because you want to know what it feels like to take a test. This is what it feels like. You see a problem, you're like, I've never seen this before, how am I going to figure it out? If you're sitting there for too long, though, it's okay to talk to your neighbor. I'll walk the room. If you have a clarifying question, I'll stop and help you. If you want to know how to do it, I won't stop. But Brooke, please. So the test on Friday, you have the entire period, but you do have to turn it in before the end of the period. Yep. To be fair, Brooke, this test, the average is usually about 50 minutes. The period's 82, so you should have plenty of time. So, go. Everyone always asks me, like, what do you mean when I say that the problems are different? Today is a really good example of what I mean by the problems are different. So.
Looking at the answer chart, so does that mean that this part right here is the heat switching with constant down or something like that?
So they're giving you a graph of f prime. So that is correct. F would be concave down. But the question just wants to know, where is f decreasing? So look at Danica's chart a little more closely. So don't think of it as velocity. That can cause a mistake. It's the first derivative of that. Correct. That was that other screen I was showing you. Yeah. That's okay. That is correct. Yep. Mm-hmm. Yeah, you only just, like, this is getting way too loud. You just, whatever's in front of you, you just use it. So. Right, so that's what I was showing you here. That lots of different ways to depict what a function might be represented by. In this particular problem, y is the function. And then the symbol right here, actually I didn't include that, let's write it on here in red. So this symbol would represent the first derivative of y. And then this symbol right here is the second derivative of y right here. So keep going. Right, that's the whole idea. Is part of what they're testing you on is, can you understand that there are lots of different ways to depict functions and their derivatives? In this case, they're using y to represent the function. You're a bit more accustomed to using f to represent the function. So, okay, let's see where we're at. So you're going to vote. So everybody votes. This is just, these are the worst things for adjusting. Okay, look, everybody votes. This means A, B, C, simple. D, E, this means I don't know. You got to tell me something. Like, even if it's I don't know, that's fine, but, and you just, you know, you don't have to show everybody, but show me. So what do you got? Show me. Okay, hands down. Let me give a hint. Remember your answer, though. So the key is, the question, look, I'm taking the test. I've never seen this problem before. How do I start? I can't start by saying, well, I've done it before. You can't. You have to say, what do I know that would help? Well, the problem is obviously testing my understanding of how these three things are associated. So if I'm taking the test, the very first thing I do is draw that on my test. So I draw that, and I look at F, and I just start reading F. And I say, okay, here F is increasing. That's from x equal A to x equals C. But wait a minute, I'm supposed to find where F prime is positive. Hey, that worked perfectly. F prime is positive when F is increasing. I feel like I'm on my way now. Okay? Show me your vote. That might be enough of a hint to help those who are stuck. So what's your vote for the correct answer? If you have the correct answer, don't let me talk you out of it. Hands down again. I'm supposed to find out the interval where the second derivative of y is negative. So the second derivative is negative whenever the function itself is concave down. So that would be here. That would be from x equal b to x equal d. But I'm supposed to find out where they are both true. Show me your vote. Come on, show me. Show me your vote. That helps some people. Again, you got to show me something. If you don't know, you got to show me a fist. Got to know where you're at. Okay, if you're doing this, and you were doing it before I gave any hints, you give yourself this many points. If you're doing this after I gave the hints, you give yourself 2. If you didn't figure it out, you've got to ask yourself, am I getting stuck because I just don't remember? Am I getting stuck because I'm just so used to doing something I know how to do? I haven't really figured out how to solve something new. Then you need to be coming in after school or before school. When you come in before and after school, I'm not going to demonstrate problems. That is a waste of time. I'm going to help you learn how to think through the problem. Okay, and we do that by discussing. So anyway, questions? Sweet. Next one. Go to number 3. Okay, on your pink reference sheet in the sheet protector, I would highly advise you to add this statement so that you don't forget it. So write that down. So the diff is for differentiable. So it says a polynomial function is always continuous and always differentiable, as are all of the polynomial function's derivatives. So what that means, Ali, is polynomial functions are everyone's favorite because they're the very easiest functions to work with. They are not very complicated mathematically. Their graphical appearance is really simple. Like if you graph a polynomial function, you get a bunch of dots that do this. Like that's a polynomial. This is a polynomial. Here's a polynomial. They're very smooth. They don't have jumps. They don't have corners. They don't have vertical asymptotes. They don't have horizontal asymptotes. They don't have anything. They're just points that are smooth. So that means you can, they'll always be continuous. You'll be able to find the slope anywhere on them. Okay. So when I see the word polynomial as I'm reading an AP problem, my brain kind of relaxes. It says, oh, this is an easy one. They're just smooth. Okay. Questions? Please, Jay. This one here is an abbreviation for differentiable. Yep. Differentiable. Like this. Like that. Please, Stephen. So we put that on your pink notes last time, but just as a quick review. A function is differentiable at a point if I can find the slope of the function at that point. The tangent slope. In this class, that's a good question, Stephen. In this class and on the AP test, when they say slope, they mean tangent slope. Yeah, if they mean secant slope, they'll say secant. 2 points. Perfect. So yeah, anytime they say slope, it means at that spot. Okay? Tangent slope. So anyway, a function is differentiable at a point if you can find the tangent slope at that point. Non-differentiable. There's a well, be careful. Any discontinuity. So vertical asymptote, jump, or removable, then I can't find the slope at that point. So let me just summarize again. So a function is differentiable at a point as long as I can find the slope, tangent slope at that point. What would prevent that from happening? If there's a discontinuity at that point, can't find the slope there. If there's a corner at that point, can't find the slope there. Vertical tangent, can't find the slope there. That's it. And I thought we put that on the pink last time, yes? Okay. Anybody else? Cool. Okay, so this is a brand new problem again. It's an AP problem. It's exactly what you should expect to encounter on the test next week. Is just something brand new. Go. Solve that one. Go to work. The goal again today, Monday and Wednesday, is to get you to feel what the test is going to feel like so you can figure out how to properly prepare for it. I don't want you showing up and saying, we didn't learn this, because my answer is yes, we did. So, the inflection point. Got it. So you really, it's like I was saying the test this morning, I don't fault you for that. Like, honestly, if they didn't have the extra hints, it's not clear that it changes there. I might say it changes there. Is that fair? It's really the hints that are helping me. Like, I just am drawn to them. Like, okay, they put them there for a reason to, like, kind of help me see where that's going to be a change. Otherwise, you can't. I don't know if that helps you at all. Well, no, that's well said. Like, because we're only looking at certain intervals. They're not asking you to be, anything outside of what you see. So, do you have any doubt as to whether this function y is concave up right there? Okay, it's still bothering you a little bit. I don't know if this helps. Think of curves that have this shape, or maybe flatten it out a lot. Okay, any portion of that curve is a concave up curve. It's not until it changes to having that kind of a shape or that kind of a shape that it becomes concave down. Oh, would depend. It's why I say the test. You don't assume what's going to happen. If it turns, it's going to go back to concave up. But if it doesn't turn, it's never going to change.
I guess with me, when I look at it, like right here, I just see concave down because this line is increasing and decreasing.
Don't pay attention to increasing, decreasing.
Okay.
Pay attention to, like, look at these pictures.
Yeah, I can see it.
Like, that's the mistake you're making.
Yeah.
So, does this curve fit on this, 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 or this? Yeah, it fits on these two.
But like to me, it looks like it's the beginning of that. Does that make sense?
The trouble is you're extending it still. It is the beginning of that because right here it switches to that.
Okay.
Like this is, like that part is concave up. When it gets to here, it's switched to that one.
It might just be a matter of practice looking at graphs.
Some of it is getting used to. Just keep asking. Show me your vote. Come on. Show me a vote. Even if it's a fist, you got to show me something. You're not going to take the test and just stare at one problem for 80 minutes. Oh, and by the way, guessing doesn't help. I had a student one time, he just tried to prove to me that guessing would get him a good score. Got 4 right. I think I told you that. It's a true story. I'm not exaggerating. Okay, 4. Guessing is not a good strategy. Can you put your hands down for a second? Here's what I would have done. I've never seen the problem before. I just have to figure it out. So I just look for anything. So I read polynomial. Okay, I'm like, okay, that means this, smooth. Polynomial has a relative max at -2, 4. Here's a huge piece of advice. In this class, I have not found it productive, watch my hand, to make graphs where you put a bunch of tick marks. Like I rarely will do that anymore. Sometimes when I'm explaining to you to kind of help, but rarely do I do that. It just takes too much time. So I just go like this, -2, 4, relative max on P. So this is P. I've memorized. That means that P does this. P can't do that because that would cause a corner. polynomials don't have corners. So, question, please. Yes, well done. So this function, which I'll call g of x, and it's on your pink notes, this is an example of g of x, come on pen, g of x having a relative max. But it doesn't work with this problem because it's a polynomial. 2 points for Allie. Okay, so I keep going. Relative min at 1, comma 1. Let's see. -2, 1's over here, 1's down, so like there. So there we go. Questions? Oh, please.
So I did a quick sketch of the graph. I did not do the effort to do every single little thing. That's just not working.
You and I are on the same page on that one, Jay. So I keep going. 2 points for Jay.
So and also,
Go ahead.
I'm connecting the lines and I changed my answer for what I said earlier because I realized I would have put the minimum to the maximum.
That would be a problem. It's okay. Okay, look. Questions so far? Okay, the next clue is this. There are no other critical points. So you have to pull from memory that P has a critical point when the tangent slope of P is 0. That means the graph of P cannot do this, because that would cause another critical point on P. So the graph of P has to do this. Question. The graph of P cannot do this either. That would cause 2 additional critical points on P. So the graph of P has to somehow smoothly connect. Last part of the question, how many zeros does P have? You must have memorized that a 0 on P is an x-coordinate where the y-coordinate is equal to 0. Okay. If you had this before I gave any hints, you give yourself this many points. If as I was helping you, you were able to figure out that it should have been this, you can give yourself 2. Jay?
I just looked at the problem rule. Do I still get 5 points?
Yep.
I changed my answer because I realized I made a mistake.
Yeah, you're okay, Jay. Anybody else? Good. Okay. I thought you were looking at me for just making sure. So. Okay, next one. Oh, yeah, please.
What's the difference between a critical point and a point of interest?
Yeah, so listen, hey. It's on your pink sheet. The key thing is this. The pink sheet says any function. That means I could be talking about f or f prime or f double prime, whatever. Any function has a critical point when that function has a tangent slope of 0. The inflection point is any function has an inflection point when that function changes concavity. Please.
So if this problem is asking how many critical points you have, it would be 2, right?
Perfect. Perfect. Listen to Ella. That's a really good way to prepare for the test, is ask yourself, am I really understanding all that they're talking about? Because that's how they make the problems different. They give you something that's kind of similar, but they ask a different question. Yeah, it's perfect, Ella. Please, Wyatt. Oh, gotcha. That's a really good question. I don't actually know the answer to that. I tend to just draw it every time because it literally takes me 7 seconds to draw it. And then I can circle things that apply to the problem I'm solving. I don't know.
So you told me to extend the graph. So then on this one, I didn't want to extend it, so I didn't know that there was zero. Could you only not
I
extend it
apologize.
if it's a specific interval or looking at a specific portion of the graph?
That is so well thought out. We'll say yes. Just keep asking me, and I'll do my best to not get you confused. I'm sorry about that. Please. So a function is differentiable at a point as long as you can find the tangent slope of the function at that point. No discontinuities, no corners, no vertical tangents. Yeah. Ian, question? For sure. Watch. I want everyone to answer this, I'll pay. I want everyone to answer it, I'll pay you. If they change the problem to say this, so it says all this, and then it says, yeah, that wouldn't help. Can't really do that. I'm not going to be able to do that. Sorry. If the function has a critical point here, Kian, that's going to eliminate that 0. Does that make sense? Yeah. Anybody else? Now, Kian, critical points here don't change anything other than if the function did this. So that additional critical point added 2 more zeros. So this is how the AP test is. They cleverly design a problem that only has one correct answer, but you've got to put all the facts together. The other thing that's different on the AP test is you are all accustomed to tests where they're checking to see if you know one thing. And on the AP test, they check to see if you know like 5 things. You had to know what polynomial meant, relative max, relative min, critical point, and 0. If you don't know all 5 of those things, you can't answer the problem. If you know 4 of them, you can't answer the problem. So that's why I say if you're feeling frustrated, come talk about it after school. Usually you're a lot closer than you realize. You're just missing one of those 5, and it's causing you to not know what the heck's going on. So, questions? Cool, next one. Moving on. Okay, we're not doing this one together. I'm just going to do it for you to make sure you're not confused at all by the idea. They give you a graph of f prime. The question says, where is f decreasing? We do exactly what Wyatt said. We take our Danica's chart. We say f is decreasing whenever I see y coordinates of f prime that are negative. I come over to the graph. See, now I've thoroughly confused you, Tess. I'm not helping very much at all. We'll just have to keep talking. I see y coordinates here that are negative. This graph really should have an arrow on it to indicate that it goes on forever. So that's my bad. So those negatives are going to just keep going. And then the other thing is, the only answer that really fits, so like I see those as all negative. So the correct answer is right here, because this is not an xy pair, that's an interval. That's saying from x going as far as you want to the left, the y values of f prime are going to stay negative.
But it's 0 at -2.
Everybody watch. This is really frustrating. I cannot get that to pick up anymore. Come on, there we go. Okay, that little, you're going to see this over and over again. When you have a graph that's hitting 0 once, here's what's happening. That's f prime. Whenever f prime has negative y coordinates, we know that f is going down. So here's f. F is decreasing. At exactly x equal -2, the slope of f must become 0. So f has a slope of 0, but only at one point, because right after that, the slope of f becomes negative again. So even though it has that one spot where the slope is 0, we still say that the function is always decreasing. So that is a case of where Danica's chart has a bit of a inconsistency. If it's just that one point, we still say the function is decreasing the entire time, even though at one point it has a slope of 0. It's because the dots themselves are always going down. Like they never stop going down. The best I can tell you is it's just a quirk. Like it's a bit of an exception that is a bit bothersome, but it is true that that function f is still going down.
Do you think it'd be easier instead of saying it's always going down to say it's never going up?
You've got to be a little careful, because if the function does this, then it's not increasing or decreasing. It's not going up or going down. But this function is going down. So I wouldn't want to say it that way. Abby?
I keep not understanding why this verse is so kind of like in my head.
It's okay.
So that one is different, like increasing or decreasing. There's no arrow to add it that. What is this one keep saying? Is it that one that's the
This one up here.
yeah.
So keep going, Abby. So this line does stop. Like the slope. So this is showing the slope of f. So drawing f, I'm not sure exactly how to draw f. Because what happens is it abruptly, in fact, it appears what this really should look like is this should be an open circle, and this would be a corner. Something like that. Okay, next one. Go to number 8. Do it. Go. Do number 8. I keep saying these are all really good examples of what you should expect on the test. Here's your pink sheet. I'm going to let you study it for a minute. But you should be studying, like you have to make sense of, this is the definition. Here's a good helper for it. And this is also a good helper. So study that for a minute. You said both things correctly. They don't really give any indication whether there is or isn't, and then they don't include it in the answer, so they're trying to tell you don't worry about it. Yep. Does that make sense? That's good work. Show me your vote. Yes. So,
I keep on forgetting.
fair enough. Write it down. So a function is differentiable at a point as long as at that point I can find the tangent slope of the function. That's differentiable. And then, like I said to Ellie, what causes a function to not be differentiable is either a discontinuity, a vertical tangent, or a corner. Show me your vote. Show me your vote. Okay, if you're doing this, give yourself this. This function has a discontinuity here and a vertical tangent here. Therefore, there are only two x-coordinates where the function's tangent slope cannot be found. So, question? Please. 0, 2. Or sorry, 2 comma 0, my bad. Right here. Keep talking, Ashley. Oh, gotcha. Hey, no, really good. Look up. Look. I'll pay Afton a ticket for this one. Listen. You have to be very specific in this class. Like, you've got to keep track. Are they telling me X coordinate, Y coordinate, you know? So here, they're telling me an XY pair. They're saying go to the point 2, 0. Right there, there's a vertical tangent. Here it says, for what values of X? That makes sense? Does that answer your question? Yeah. Hey, everyone. The level of precision required to be successful in this class is much higher than most any class you've ever taken. Like, you have to be very attentive to details. Other questions? Cool. Next one. Okay. This is number 9. Okay, before you begin, listen, before you begin, this word, twice differentiable, I need to make sure you're not confused as to what that means. We've just got done saying like 6 times, sorry for the sarcasm, that differentiable means at a given point you can find the slope of a function, okay? When they tell us that a function is twice differentiable, they're saying the following. This function here is f. F is twice differentiable, meaning at each and every point shown on f, you could find the tangent slope, which means you could find the y-coordinate for f prime. If you took all those y-coordinates for f prime and created a graph, you would then be able to find the tangent slope at every point on f prime, meaning you'd find all the y-coordinates for f double prime. That's what twice differentiable means. The mistake many people make is they think twice differentiable means we are looking at f double prime. That is incorrect. We are looking at f. Questions so far? Go ahead, Jay. What's that?
I zoned out for a second. So differentiable means again twice differentiable.
So twice differentiable means you're looking at f, but you can also find f prime and f double prime, but you are looking at f. That's what twice differentiable means. Good? Okay. Please, Holly. Oh, yes. Yeah. Most commonly, we are working with functions that are twice differentiable. Like polynomials, those are infinitely differentiable. This one here, actually, everybody in the room, raise your hand, please. This function, raise your hand. Is it, actually do it with your hand like this. Is it not differentiable at every point? Is it once differentiable at every point? Is it twice differentiable at every point? Show me. At every point on this function, is it twice differentiable? Meaning you could find the slope. I didn't explain that very well. Hands down. This one is not differentiable at every point. You can't find the slope here. You can't find the slope here. So this is a function that is not differentiable at all at every point. This function is twice differentiable at every point. You can find the slope everywhere. Those slopes become y-coordinates for f prime. You then take those y-coordinates, make a graph. That becomes the graph of f prime. You can find the slope everywhere on that graph. That becomes this graph. So, they're not saying you can't. They're not saying you can either. They're just saying twice. This clue gets given in many AP problems. Typically not a clue that I have to stress too much about, but sometimes. So, Hallie, I don't know if I answered your question. Okay. All right. Oh, one more thing, Ellie. Sorry. Hey, look. Just a test hint. This isn't a math rule at all. This comes from studying multiple choice questions that cover like 50 years of the AP test. when you see this pattern, this less than thing, here's what I would think right away. The middle one's probably going to equal 0. The one on the left will be some negative number. The one on the right will be some positive number. Okay, I've seen the AP test for a lot of years. Whenever I see this pattern, that's what they always do. They could be very, very clever and design a problem where one is negative, one is less negative, and one is positive. They just haven't. Ellie, you had a question, sorry. Go ahead.
Why is the domain of the derivative not the open interval?
That's going to take a little while to explain, so hold on that one. Do this one, go. Another really good example of what it's going to feel like to take the test on next Friday. So hold on. Go ahead. So the idea is the derivative of f is f prime. So that means f prime is a whole bunch of xy pairs, right? What is the y value of f prime always representing? Of f, tangent slope of f. So the domain of f prime is going to be all of the x's where there is a y value for f prime. Does that make sense? That's what domain means. Good? So, in fact, we got a list here, x, f prime. All the x's for which there is an f prime. F prime is all of these come from the slopes of this. So is there anywhere here where you cannot find the slope? Right there. That means x equals c is not in the domain of the function f prime, because at x equals c there will not be a y coordinate for f prime. Does that make sense? This says the domain of the derivative is the open interval a to b. That means the domain includes all of the x coordinates from here clear to here, which would include c. But c is not in the domain. I don't know if I've held. Okay.
I have another question for us too. What is a line tangent?
So we've been doing that, how we'll show a curve, and we'll say we want to find the tangent slope.
So it's just the same.
And if we extend it out, it becomes the line tangent. So,
like that problem last time.
yeah. Okay, show me your vote. Come on. Show me your vote. Show me your votes. Show me what you got. Okay, hands down for a second. Let me give you a hint. Remember, if you have it right the first time, your points are much higher. What I would have done is this. They're showing me f. F of 1, right there. F of 1 is 0. So I know it's one of those two. Questions? Yeah, please.
But in the form of the graph after something,
No. Twice differentiable f means you are looking at f, but f has two derivatives. Yeah, no worries. Please. Oh, listen to Adelie, please. Hey, that's really good. Look, the reason I know that I'm focusing completely on x equal 1 is because of the answers. Because every single answer is talking about an x coordinate of 1. Does that answer your question? It's okay. Does that make sense? No worries. That's why we practice. So, anybody else? Okay. Next thing I would do is I'd say, well, at x equal 1, I can literally see what the tangent slope would look like. That is definitely a positive tangent slope. Show me your vote. Go like this if you don't know. Don't Fold your arms. So if you're doing this, you get this many points. So I know the f of 1 is 0. Okay, we're doing this starting today so that if this is not clicking, you've got to come sit here after school. And you got to talk. You got to open up. You got to discuss. If you're waiting for me to show you how to do calculus, you're going to be waiting a long time because I can't show you how to do it. I can talk with you and get you to see it for yourself, but if you don't see it for yourself, you won't succeed on the test. It's impossible. Okay? And look over here, look. I guarantee you, calculus is not the only class that is like this. I may have shared this story, I don't remember. Had a student, took my class, went to Utah State, enrolled in freshman psychology, and noticed that for the first several weeks, most of the students were failing the quizzes. And they're all like complaining to the professor, "You're not teaching us what we are seeing on the quizzes." My student was doing just fine because she had learned that you don't have to like just regurgitate what somebody gives you. You have to think about the ideas, okay? So this is not the only class that will force you to do that. Like you have to shift from the high school mentality of somebody shows me what to do and then I do it, to can I really figure something out on my own? So, questions, please.
How come F double prime is negative?
Because if f is concave down, every y coordinate of f double prime will be negative. Show you after class on that one, Jay. Go to number. Go to number 14, go. Sorry, it's 13 in your packet. I renumbered, I took one of the problems out. So go to 13 in your packet. The pictures will match. Go to 13, go. Go to 13. So look here, Jay. If you have a curve that's concave down, then there's going to be all these different slopes. That makes sense? Slope is decreasing. Very good. So f prime is the slope positive or negative? Positive, but decreasing. That means the points on f prime are going to be positive, but they're going to be becoming less positive. Something like that. Is that okay? So let's keep talking. So now if we go find those slopes, what do we find out about all those slopes? Those slopes are increasing. They are negative and becoming less negative. So the graph of f prime looks something like this. F double prime. So every f double prime value is negative. That was your question, right? You're welcome. Okay, look up. We only got a couple minutes before the bell. Hey, couple minutes before the bell. Open interval means we're talking about from one x to another. It's better to start with closed. Closed interval start means start at exactly x equal a. Go to exactly x equal b. Open means start at an infinitesimal amount more than a. Go to an infinitesimal amount less than b. That's why it says open. Look up. The reason they say open interval is this. When we go to find a tangent slope, we're trying to find the slope at one point, which is impossible. I don't know how to draw a slope at one point. I've got to have another point as a reference. Technically, to be mathematically correct, I've got to have a point on the right and a point on the left. Because as I believe we've talked about, you go a point to the right and you make a secant, and then you go a point to the left and you make another secant. And as long as when you make those secants very, very short, the two slopes become infinitesimally close to the same, the idea of a limit, then we know the slope at the point. So you can memorize this. At the end of any function, like if the function literally stops, you can't find the slope at an endpoint because there's no way to make a secant to the left. Or over here, there's no way to make a secant to the right. So that's why the question has to say open interval, because you can't find the slope at the end. So the question says the domain of the derivative. Derivative is f prime in this case. F prime represents the slope of every point on that graph of f. So all these slopes are the same. I don't know, maybe they're all 2. So at x equal a, I don't know the slope because I can't find the slope at the very end. But at x equal a plus a tiny bit, like that, I can find the slope. It's 2. I keep going. When I get to point C, I can't find the slope again because of the corner. When I get to a little bit past C, something like this, I can find the slope again. When I get to exactly B, I can't find the slope again. So that's why this is false, because I do start a little after A, I do stop a little before B, but I can't find the slope at C. So good job, you guys. We'll do this again on Monday, so good work.
Thank you.
You're welcome. So really, my best advice is you want to get as much done as quickly as possible. Like due dates really don't make any difference at this point. It's the test is Friday. The quicker you get it all done, the more you can come talk about it. So.
Use Danica's chart on this, like, would this be considered concave down or something?
That would be considered not concave at all.
Okay, but could you use it for other things? Like, could you say that this part of the graph is still increasing?
You could say f is increasing, therefore f prime must always be positive.
Okay.
The trouble is it doesn't work right there. Because of the corner, f prime is undefined. Keep talking. Let me stop the video. Hold on. Keep going, Wyatt.